Alright, this is the geometry definitions video. The first definition is a point. Points have no size and they represent position only. So when you are naming a point, you can name it by drawing a point and naming it, like point P, point Q, okay? Or you can write out the word point. So point P or point Q. Okay, you'll see us using the notation with the drawing the point. The next definition is a line. Lines extend indefinitely, that means forever and ever in both directions, and they have no thickness or width. Line includes all points on the line. So if you have a line, let's pretend that's straight, this line will go left forever and ever, and it will go right forever and ever, and any point on here, any of these, would be points on the line. Okay, it doesn't really matter how thick you draw this line. If you draw it super thick or super skinny, a line really doesn't have any thickness. It just represents that those points in space. Okay, when you go to label a line, if you pick 2 points on the line, like point A and point B, you would name the line AB with a line over it. So it would have to have the arrows. The arrows mean it goes left and right forever and ever. Or you could name this line BA. Let's say we add point C in here. That's great. We can also name this line AC with 2 arrows, CB, or we could name it CA with 2 arrows, or we could name it BC. Any of those names would be correct. So any 2 points on the line can be in the name in either order, as long as you have the correct notation, the 2 arrows above. Alright, a segment in geometry. A line segment is a part of a line that is bounded by 2 distinct endpoints and contains every point on the line between its endpoints. A closed line segment includes both endpoints, while an open line segment contains both endpoints. A half open line segment includes exactly one of the endpoints. So if you have a line, okay, that goes on forever and ever in both directions. A line segment would be from one point, one endpoint to another. So only this red section would be considered part of the line segment. Okay, so when you name line segments, you would want it to start at A and end at B, and you would not have arrows above it. That would tell you it's only that red section, not left and right forever and ever, only from A to B, or only from B to A. Either one of those line notations would be correct. This whole open endpoints and stuff is talking about if you had a line segment drawn like this. This would mean from A to B, but A would not be part of the answer. Okay, and you'll see that more when we do like inequality stuff. Alright, array is a line with a single endpoint or point of origin that extends indefinitely in one direction. So for array, it has a point of origin, the endpoint, and it goes in one direction or the other. It does not go in both directions. So if I'm going to name this ray, I would start with whatever the origin is, the endpoint, and another point on the ray. So this ray is A, B. It is not BA. You have to put the endpoint or the origin first, and then the another point. ray BA, if I was to name ray BA, that is not this black ray. Ray BA would look like this, B being the origin and A being another point. Okay, if you get these backwards, you're incorrect. You have to put the origin or the endpoint first in the name, and you have to use one arrow, okay, not two. Two arrows would be a line, no arrows would be a segment, one arrow is a ray. It's very important that you use the correct notation when naming. Alright, opposite rays are rays with the same endpoint that lie on the same line, and they go in opposite directions. So in reality, opposite rays look like a line. Okay, it'll be a line with a shared endpoint. So let's say A was both of their endpoints. Okay, so you could have a ray going in this direction. That could be ray AB. And you could have a ray going in the opposite direction as AB, and we could have that be ray AC. Opposite rays are really a line, but I can cut a line into two pieces and say, okay, I'm talking about this part of the line going in this direction, and I'm talking about the other part of the line going in the other direction. They're going in opposite directions. Okay, it looks like a straight line, and it is, but we can cut it into two chunks. Okay, one going left, one going right, one going up, one going down. Okay, they're just two rays going in opposite directions. Alright, planes can be thought of as flat surfaces that extend indefinitely, so forever and ever and ever in all directions, and they have no thickness. So we think of planes as things like pieces of paper, walls, the floor, the countertop, but in reality planes are flat, but they go forever and ever. In a textbook or on a worksheet, they'll usually look kind of like this, kind of like a wonky square. Okay, and they really do go in, you know, directions forever and ever. They go left, they go right, they go up, they go down, they go forever and ever. Okay, but they'll look kind of like a wonky square. When you go to name a plane, you can name a plane using 3 letters, 3 points that are in the plane. So like point A, point B, point C. As long as you have 3 points in that plane, you can name a plane using 3 points. Plane A, B, C, plane C, B, A, plane B, C, A. It doesn't matter the order. Any 3 letters can be used to name a plane. Sometimes you'll also see a plane labeled using like cursive letters. So cursive uppercase letters. So let's say that's a fancy cursive R. You'll also see plain fancy cursive R. Okay, so it just depends on what textbook or worksheet you're working with. Collinear points are a set of points which lie on the same line. So if I have a line, any points that are on this line would be collinear. This point, this point, this point, this point, any point in here is collinear. If it's not on the line, then that would be not collinear. Okay, collinear points are just simply a fancy word for saying that they're on the same line. Like just stated, non-collinear points are points that are not on the same line. Okay, any 2 points can be on the same line, so if I just draw 2 random points, then I can draw a line through them, or can I? Okay, so those would be collinear. But as soon as I add a 3rd point in, that point can all of a sudden not be collinear. So these 3 points, all 3 of them together, are not collinear. Coplanar points are very similar as collinear points. Coplanar points are a set of points that lie on the same plane. So usually in a book or worksheet you'll see a plane kind of drawn like this. Any points that are drawn on the plane would be collinear. Okay? Any point that's drawn off of the plane is coplanar. A lot of times you'll see a line drawn and then you'll see it dotted. This means it's going through the plane. Any point on this line would be non-coplanar. Okay? But any point on the plane will be coplanar. Again, as just stated, non-coplanar points are points that are not on the same plane. Again, a lot of times you'll see them drawn on that line that's cutting through the plane, but not actually on the plane. Alright, intersection is the set of all points that are in both figures. This can be thought of as where the two figures touch. So like the intersection on the road. Okay, that's where two roads meet. Okay, you did intersection last year in Algebra 1 probably, where the system of linear equations, where the two lines were touching was the answer. That's the intersection. Anything that's touching. But it's not just with lines. It can be with a triangle and a circle. Anywhere that that triangle and that circle is touching is called the intersection. So it's not just with lines. You've done lines already, the intersecting lines, and you'll see a lot of that this year in geometry, but all kinds of shapes can intersect. Squares can intersect with squares, triangles with triangles, lines with triangles, stuff with circles. So any place that two shapes or figures are touching is called the intersection.